Hello everyone, my name is Khairul. I am a fifth year CH PhD student at the University of Virginia, and my research at the AI Institute for Cosmic Origins focus on using machine learning techniques to solve interesting problems in astrophysics. And today I'll be presenting our recent work Cosmo3DFlow, a generative model designed to reconstruct the initial condition of our universe. Now, our goal is to work backward from the complex cosmic wave to see how the world would look like during the early universe, especially close to the time of the Big Bang. But how can we do that? We can actually see how our present universe looks like, the dark matter density around us, and we can actually use that to back calculate how the universe would look like 13 billion years ago. And that is the problem we are solving. But the biggest challenge in solving that problem is the very high dimensionality. So you have to actually iterate over a very large regions of data, which on a CPU takes a very long time. That's how recent deep generative models are actually trying to solve that problem by creating probabilistic models that are way faster. Now, this is how the problem actually looks like. So we have like dark matter density on the left from the present universe, and we are using that to generate the initial universe. Now, the biggest challenge is space is mostly empty. So just using it as it is now is quite challenging. So we actually propose a wavelet flow matching model where we compress the data in the Fourier dimension, but also use flow matching to increase the convergence speed. So as you can see, we actually get way more faster speed, like more than 4 times compared to a traditional diffusion. But we also get that almost like 50 times more efficiently. But how good is our accuracy? So on the picture here, you can see zoomed in versions of the resolutions, and our model is very accurate and very small regions also. So we can calculate more finer details from the data itself and give very good quality predictions. But what is the next challenge, basically? So the more we keep going into the higher resolution, the computation also increases drastically. And at one point, traditional A100 GPUs will actually not be enough for our task. So that's the one we are actually currently working for the future, to how to handle very high resolution data while still being as accurate, while still actually fitting everything inside the GPU. So that's the goal we are working right now. Thank you for listening.